Okay.
All right. Closing the door here. Okay. What is going on? It's Mr. Nelson here. And my collar's bothering me. Straight from the 403 to the HAZ. Jesse! Hey, Jesse, come here. Come say Merry Christmas to the video. Come on. Come say Merry Christmas. Come say Merry Christmas. Oh, there's Jesse. Jesse says Merry Christmas. This is my little boo. Okay. All right, let's do this. Let's grow up. We are now into, we finished radicals, and now we're jumping into rational equations. But Mr. Nelson, what's a rational equation? Great question, I'll tell you. A rational equation is basically any equation, any division, where we have a variable on the numerator and in the denominator. So some examples of rational equations would be something like x over x minus 1. We could do x squared over 2y. X squared minus x plus 1 over x. Any equation, or any division where we have a variable in the numerator and the denominator. So some examples that are not rational equations are something like 1 over x minus 1, or x squared over 2. In these cases, either the numerator or the denominator does not have a variable. Simple enough, isn't it? So, just to clarify, x minus 1 over 3 minus 4. That is not a rational equation. There's no variable down here. We need some letter, some variable down here to make it a rational equation. So, with that definition in there, let's start playing with some rational equations. So I'm actually going to grab my textbook just so I can give some examples. So say I had something like x minus 1 over x minus 2, x minus 3. Actually, we'll make it even simpler. Let's just say I had something like x minus 1 over x minus 8. Okay? So when I'm dealing with an equation like this, I start to look at a concept called NPV, or non-permissible non-permissible, I hope, values. So basically what does permissible mean? Allowed. Not allowed. So values that are not allowed. Non-permissible values. Values that we cannot allow. And what does that mean? Values for x. So what values for x are not allowed? Well, why would a value of x not be allowed? Well, let's remember, we cannot divide by 0. When we divide by 0, something becomes undefined. So if and when I were to plot a graph like this, what we would see is when x is equal to 8, well, I'll get x minus 8 is 0. 8 minus 8 is 0. So I will actually get 0 in the numerator. And then when x is equal to 8, I'll get 7 divided by 0 when x is equal to 8. That's what this will work out to. So if I were to plot this, I would get something. I'm not exactly sure what this one would look like, but it would look something like this. We'd have a graph that would basically come around that 8, but it would never actually be 8. It's just going to get close to 8, but never be 8. So that's what this graph, if I were to write y is equal to this and graph it, it would turn out like this, where it goes crazy at 8, because at 8 it becomes undefined. So half our job in this new unit of rational equations is just identifying where our denominators will become 0. And then once we can do that, then we can start simplifying. So let's get a little more complicated with this, slightly more. So let's say I have an equation, an equation like x minus 1 over x minus minus 1, x minus 2. Okay? Step 1 in this kind of problem is to first, we're always going to look at the non-permissible values first. So my NPVs. So in this case, what values of x will make the denominator 0? Well, just looking at it, if I give x is equal to 1, this becomes 0, and then this becomes negative 1. But 0 times negative 1 makes this all 0. So 1, x is equal to 1, is a non-permissible value. The other one is going to be 2, because 2 minus 2 is 0, and then 2 minus 1 is 1. 1 times 0 is 0. The denominator will be 0. So for those two values, which I pull out before I do anything else, this will go undefined. Now I can go through and I can just cancel like terms. So in this case, I can simplify this because x minus 1 will cancel with x minus 1. Just the same way that 2 divided by 2 times 3, I can cancel this away, and this just becomes 1 over 3. Because this is the same as 2 over 6. 2 divided by 6, which is 1 over 3. So I can cancel out these 2's, and in the same way I can cancel out binomials as well. So ultimately, my simplified version of this equation will simply be 1 over x minus 2, where x cannot equal 1 and 2. Okay? That is simplifying rational equations. Now in this case, we were pretty friendly and we left it in pretty easy form, like we've already have it factored. So this was an easy question. So what we might start seeing now is just slightly more difficult questions where we have to actually do a little bit of factoring. So let's say I've got something like okay, let's say I have something like 3x minus 6 over 2x squared, okay, I'm not going to go that crazy, over x squared plus 4x minus 12. That should work, okay? So the first step when trying to simplify a problem like this is to factor it. And let's remember, there's 3 real questions we need to ask ourselves when factoring anything. The first one is, that's the one I just tried. Okay, oh. Whoa, sorry, Jesse, I almost hit you. First one is, do I have any common factors? Common factors. AKA, are there any numbers or variables that are common across the binomial or trinomial or polynomial that I can pull out? So common factors. That's the first question. Okay, second question is it a trinomial that I can use product sum factoring? Product sum being 2 numbers that multiply to this number and add to this number, and then we do that whole process. So negative 12 and 4 in this case, right? So in this case it would be 6 times negative 2 multiplies to negative 12 adds to 4. So I could already factor this. But so the next is it a trinomial where I can do product sum? And to do product sum, I cannot have a number or in front of my squared term. So if I do have a number in front of my squared term, then it's like, okay, I gotta do decomposition. Decomposition is just another way of factoring. In this case, I will look at the top first, and I'll go through my steps. So are there any common factors here? Well, I can see that I can pull out a 3. So I get 3x minus 2. Hey, can you stop making noise, please, so I can do my video? Thank you. So I do that up here. Now I'll look at the bottom here, the denominator, and I'm going to do I figured out that my factors are, I banish you, please. I need to make my video. You can sit, you can watch the genius happen, but you can't participate. So let's go with K. Right now, I've got it all factored through. Ladies and gentlemen. Yeah, that's right. Now I've got it all factored. Now I can look at my non-permissible values. So what values are going to make my denominator 0? Well, clearly, when x is equal to 2 or negative 6, this will be 0. So now that I've got my non-permissible values, I can go through and I can just cancel out like terms. So there's an x minus 2 on the top and bottom, those go away. So that my final answer is 3 divided by x plus 6, where x cannot equal negative 6 and 2. Final answer. Oh my God, we survived that. Gee whiz. You get no respect around here. Absolutely no respect, and I want some coffee now. So that's that. The hardest part of this unit is really just factoring. So now let's do one slightly more difficult problem. Something similar to this, but we'll just increase the complexity slightly. So I'm going to go through the same steps. So let's say I had x squared plus x minus 6 on the top, and then on the bottom I had 2x squared plus x minus 10. Okay? So, first step in simplifying is to factor. So I'll factor the top. The top looks pretty easy. Any common factors? I cannot pull out an x because there's no x here and there's no numbers I can pull out. So check. I've done common factors, there's nothing I can do. Next, is it a trinomial where there's no number in front of the x squared term? Yes. So I'm going to do product sum. So let's do product sum here. Okay, two numbers that multiply to negative 6 and add to positive 1. Those two numbers are, well, let's try negative 6 times positive 1. That makes negative 5. So how about 6 and negative 1? That makes positive 5. Okay, how about 3 and negative 2? That makes positive 1 when I add them. So those are my factors. So on the top, this will be x plus 3, x minus 2. On the bottom, I'm going to go through my process again. Are there any common factors? Well, I have x here, but no x here, so that's not common. I could pull out a 2, but there's no, what's the word I'm looking for? There's no number here that I can pull out. No multiple of 2. Multiple of 2 here that I can pull out. So I skip the first step. I have no common factors. Is it a trinomial? Yes, but there's a number in front of my x squared term. So now I can't do product sum, I have to go to decomposition. So let's do decomposition. If we recall, I'll do it up here, decomposition works this way. Actually, I'm going to erase this, I'm going to do it right here. So I've got 2x squared plus x minus 10. Now the first step of decomposition is to multiply the first term and the last term. So 2 times 10, negative 10 is negative 20. Now I make my table. I want two numbers that multiply to negative 20 and add to positive 1. Add to positive 1. And those two numbers are going to be 5 and negative 4. 5 times negative 4 is negative 20. 5 plus negative 4 is positive 1. So now I can replace this number as an addition, as a sum of these two. So I can rewrite it now as, so right here, if you can see, 2x squared plus minus 4x, because I know that 2 and 4 are multiples, so they're probably going to work out, plus 5x minus 10. Now it doesn't matter what order I put these in, because it'll work out either way, but this will be easier for me here. So now I'm going to factor each of these. And I'm going to pull out a 2x here and get x minus 2. And then that's a hint. I'm going to have x minus 2 over here. And then plus 5 times x is positive 5x. And plus 5 times negative 2 is negative 10. So if I factor out now this out of both of these, I will get x minus 2 times 2x plus 5. So these are this is my factored on the bottom. So I'm going to get x minus 2 times 2x plus 5. Now, I have to decide, now that I've simplified it, or sorry, I've factored it, now I do my non-permissible values. Before I cancel anything, I'm going to do my non-permissible values. So my non-permissible values, I'm looking at my denominator. And I can clearly see if x is equal to 2, this will be 0. And if I make this equal to 0, 2x plus 5 equals 0, and I solve it, I get negative 5 halves. So my other non-permissible value will be negative 5 halves. Now, all I have to do is cancel my x minus 2 and x minus 2, and write my final answer as x plus 3 over 2x plus 5, where x cannot equal 2 or negative 5 halves. Simple enough. Follow the steps. So to recap, you are going to factor first, going through these steps where it's either going to be common factors leading into trinomial, or just a trinomial that you have to decompose, or product sum. So you're going to factor it, then you're going to do your non-permissible values, and then you do the canceling out. So the non-permissible values will stick around even if we cancel out this denominator term. Okay, I will be making more of these videos today, hopefully. Thank you, bye.